title of the presentation is Productivity in Engineering and Design to Manufacture. A little bit about myself. I have an honours degree in engineering, a postgrad in computer programming, and also hold an MBA in business administration. I've worked in the industry as process designer before co-founding Solid Solutions in 2002 with my colleague Seamus Shanahan. And what we do is we're Ireland's premier SolidWorks reseller, and we help our customers identify how they can improve their design process right the way through to manufacturing. This can be anywhere from 3D modelling techniques to software implementations and knowledge management. I'd just like to bring your attention to something that happened in 2002 that we were involved with. And in 2007, the Department of Education implemented 3D CAD as part of the Leaving Cert curriculum. This was the first time since 1974 that changes were made to the tech drawing subject. The subject was rebranded DCG and gave our young budding engineers access to software that was used in industry. The results have been amazing, with students aged between 16 to 18 winning global competitions and awards. They are now understanding the design process and have been introduced to many aspects of engineering that they never would have approached in the past, such as design, simulation, analysis, and CFD, so on. But what I'm looking at is the productivity revolution, and engineering productivity has been driven by better engineering tools and processes, and this has led through a dramatically higher manufacturing output from 1950 to the present date. And this has all been possible through leadership. The design process and improvements of your organisation's design to manufacturing process requires leadership. Not only leadership, but visionary leadership. What are your competitors doing? How are they doing? What are they using? Can we do it? And can we do it better? Because many of the Irish organisations that we deal with today not only have the charismatic and visionary leaders, but they're bringing their company up to date, but also forging the way for the future. And I've put engineering into 4 different categories. Engineering 1 right the way to 4. And if we take an engineering 1, the industrial age, we're looking at the manufacturing process at this point. Thomas Newcomb's steam power engine was the leader, and all steam engines followed suit. But the Industrial Revolution was the transition to new manufacturing processes from that period of 1760 to 1840. Like now we see 3D printing forging the new ways of engineering today. We moved from hand tools to machines. Chemical manufacturing was invented. Water, steam power, wood and biofuels moved to coal, which is ironic, we're moving back to biofuels now. But Industrial Revolution was the beginning of economic growth in the capitalist economies as we see it today. 1840 to 1870, large manufacturing machines, the spinning jenny in the textile industry moved away from hand weavers. Henry Ford in the 1920s, seeing that the manufacturing process, he needed to get his product to market quicker. What did he do? He told us we could have the Model T Ford, we could have it black, and that was it. Any colour we wanted, but black. So we've moved from the manufacturing process, from our 2D drawing on a drawing board, right the way to the digital age of the 1960s to the 1990s. We moved from lines, circles, arcs, to powerful 2D solutions and 3D solutions. Designers, believe it or not, were using computers to calculate computations or optimization back as far as 1949. But it was only in the 1960s when MIT developed Sketchpad, which was a 2D sketching tool. Evolutions and designs in this industry over the period of the 60s, from aircraft, aeronautical and aerospace industry, led us to 3D surface constructions, NC code for machining. And in 1966, French engineer Pierre Bezier developed the whole area of 3D CAD and CAD-CAM. His research and his kernel led to the industry standard in the aeronautical and automotive industry for 3D design, which in turn led to designs like the Boeing 747. Mobile phones were developed in the 70s. So we were already changing our process in design at that point. we were doing 3D design. We were analysing, albeit maybe by hand, but we were using computational methods for our designs. It was expensive, and small SMEs at this point were still probably in the industrial age. We move now to the information age, and the age we probably are currently at. And where does your company fit? Because we have now moved away from 2D design. You've seen all the great talk about 3D printers. You can't transfer your 2D drawing into a 3D printer. It has to be a 3D model. And we've seen engineers are using 3D design tools now that have been made affordable in the event of mainstream CAD in the early 90s with SolidWorks. We now can design up front, do interference detection, collision detection. We can also analyse our products. We can do FEA analysis. So we're actually making decisions earlier in the design process. In doing that, we have created an awful lot of knowledge about our design and our products and our manufacturing process, whether that be explicit or tacit knowledge. But are we capturing that information efficiently or effectively? Or are we capturing it at all? Recently, as part of my role, I was called into a customer of ours where they designed a machine, say 5-6 years ago, did all the testing on it. They recently got a repeat order for a similar machine. They couldn't find that design. They didn't know where it was gone. It was on a Z drive, it was on a C drive, maybe it was on someone's USB key. They had no control over where it was gone. They were back to the beginning and redesigning that data they had lost. So we have all this information, and this is engineering tree. So as I said, we're doing our modelling in SolidWorks or in whatever 3D package it is. We're doing our collision detection, tolerance analysis, all being done up front. We can do some analysis on FEA, frequency, buckling, fatigue. Are we capturing that data? Because the tools are there for revision control, document management, understanding what we can use again. How many legs of the stool is your company using? 1, 2, or 3? And surprisingly, we have a long way to go on a recent survey that 65% of companies are still hobbling on maybe 1 to 2 legs. So engineering 4 is the automation age. And we're actually told that 26 billion internet devices will be connected by 2020. By 2025, the US Air Force will be controlling their skies with 30,000 drones. We're not going to drive our cars anymore because we'll be all having self-drive cars by 2035. And Google's director of engineering has estimated that computers are going to be cleverer than ourselves. So today we need to get up to date in using that usable 3D information, whether it's sending it directly to a 3D printer or capturing the design we've got. CAM, PDM, digital mock-ups, PLM, and so on. So let your engineers do the design is probably the message I'm telling you. Let them be innovative. Because recent surveys are quite alarming, that an engineer is spending 30% or 4 hours per day helping other departments. Recently, Rolls-Royce carried out a study on what their engineers were doing. And alarmingly, 30% of their time was searching for data. So knowing and having that knowledge is key. So we can see, half of our engineers' time is lost throughout the working week. So we can improve our design process. So currently, a lot of companies may be working on a serial process where concept, detailed drawings, then we maybe go do a validation, and then we do a technical document by getting out the digital camera and taking the photograph. We need to shorten that value analysis. And we can do that using software as proposal, where we can design, we can validate our design, we can manage our data, and also have technical communication software there as well that can run concurrently. That's helping your organisation make better decisions earlier, saving you money. All engineers or all machine processes also use electrical software. The same can be said. We can do our electrical design concurrently with our manufacturing, validation, technical drawing and data management. Again, saving more money and better decisions at an earlier process. So I'm going to just finally wrap up. Just the current workflow that we generally see is an 12 to 18 month workflow. That can be reduced by 40% using the correct processes and softwares that are available to you today. Just some feedback that we get from exact customers. One particular customer in the packaging industry cut manufacturing release times by 80%, replaced paper drawings with 3D models, and they also did a lot of 3D printing and were able to see quality of their product before they shipped. Again, one last one. Engineering, accelerated time by 50%, cut design cycles by 30%, decreased scrap and rework by 50%. There is no longer an excuse that we can model something, take it out to the shop floor and all of a sudden don't find it fits. This can all be done up front on software. So we're reducing our development costs as well. So I'd like to thank you for your time. If there's any questions. Thanks.